together before. So Chouette is kind of, taking all the lessons I've learned in all of the servers I've built before and gluing them together and making them work in a kind of a nice package. So maybe you'll find it useful for applications if you want to, but all the modules work standalone too. So if you want to import them into your own async applications, you don't need to use Chouette. So the four main modules that Chouette glues together are any event task, which is a way to delegate blocking tasks. So if you have database access, password hashing, stuff like this, normally you don't want to use those directly in an asynchronous server, right? Because they're going to block the event loop, right? And then all the event loop is blocked. You can't do other processing. You can't handle more requests. So any event task is kind of this process pool that you can delegate your stuff to. And then the next module is a callback frame. And it's kind of a way to handle error handling and other dynamic state management in a kind of structured way, right? So the idea is that you can use exceptions anywhere, right? A lot of asynchronous servers and things have kind of tough time using exceptions, right? Because if you're in the middle of an event loop and you throw an exception, the event loop catches it, and it doesn't really know how to map that to the right request or anything. And then the third module that Chouette glues in there is log defer. And log defer is kind of a way to add structure to your log messages, so that when you log events, you log data, it's logged in a way that's easily parsable, and it provides some nice tools for that. And finally, session token, I've talked about that before. It's a way to generate good quality random identifiers. So the really high level way to use Chouette, and I'll show like a hello world in the next slide, but basically what you do is you just create a Chouette object, and then you can pass in parameters to the Chouette constructor. And one of the things you pass in is different routes you want to handle. And then after you've created your Chouette object, you call run, the run method. And then Chouette accepts requests and it invokes handlers. It's pretty standard kind of HTTP sort of server architecture. So here's the like hello world basically. So you can see you use Chouette, and then you create a Chouette object, and then there's those two are the main config things you need to pass in. You need to give it like a var directory where it's going to put logs and Unix sockets and some other stuff, and then where you want it to listen. So if you want to listen on a port or a Unix socket, you pass it in there. If you want different interfaces, you can provide that. And also, Chouette comes with a config file parsing integration too. So if you want to override these in a config file, Chouette also handles that. You can provide a YAML config file. And then after you've set up your config, you want to handle routes. You want to provide routes. So here's like the simplest possible. You give it a slash and you say, get requests. I want to invoke this callback, this sub. And then as you can see, the sub gets this context object, the $C, and then you can call methods on that. In this case, it just calls respond. And then, once you've created the Chouette object, you just call the run method, bang, your server is working. So here's kind of what happens after when you want to run that. You can just run Perl hello world app.pl, which is what I've called this. And if you have modules in your lib directory, you can include them there. And then it kind of prints out some just information about what it's doing. It says where it's listening, what the UID is that it's running as, and it also gives you a command you can run if you want to tail the logs of it. And that command tails them in real time and shows them in a nice way. And then as you can see, you can just run curl, bang, and it does exactly what it says, the hello world. So this is all pretty standard sort of Plaque application sort of stuff. Like you can do most of this with other servers. The interesting things about Chouette are sort of the integration that I'll show you in a second here. So the first thing is the routes. So previously I just showed routes as a simple sub callback, but you can also map them to package and functions by providing their fully qualified function names. So if you have like a resource and you want to route requests to /my_API/resource, and you can provide the package and function names there. And one thing I've tried to do with Chouette is to provide like nice compile time error messages, right? So if it boots up and it won't like give a 500 error at runtime, for example, if you forgot to implement a method, it'll show a nice compile time error message. and say exactly what route it wasn't able to resolve. Yeah, so the next thing is context objects. So all of your handlers accept this thing called the context object, and that's how your callbacks interact with the request, and do things like respond and set headers and so on. But yeah, basically it's the just first argument passed to all of your handlers, whether they're subs or fully qualified package functions here. So another thing you can do with routes, and this is pretty standard too, is accept parameters in them, right? So you can go colon resource ID I have here inside your route, and that will accept anything you put there, right? So if you want to put a user ID or something like that, it gets mapped, it gets captured and is accessible to your routes. So for example, here I've implemented a delete handler, and I get the context object, and then you can access that resource ID with this C route params resource ID. And the way that's implemented is that all the routes are compiled to a regex with regex assemble. So you have a whole bunch of different routes. One thing that you could do is just scan over every single route in a loop, say, does this one match? Does this one match? Does this one match? But that if you have a lot of routes, it's not quite as efficient as having a regex, which can implement kind of like a trie sort of data structure. So here you can see that suppose you have all these routes that start with /foo, right? Well, the regex that it compiles down to begins with \a. That's just means the beginning of the string, right? It's another way of writing caret, but it's a little bit different because it doesn't ever match new lines, like a new line embedded. And then it says, because all the routes began with /foo, I'm going to match /foo, and then all of them actually begin with B too, right? I have bar and blah, so it says I have 2 branches to go down. I have the AR, that's for bar, and then if I'm doing that, then I have some stuff after that. I can go either /junk and then end, or I can go /junk and then capture this ID. And if you guys are familiar with named captures in the regexes, that's how the route parameters are implemented. So you have question mark, open angle brackets ID, and then it's accessible to dollar forwards. I don't remember, dollar something or other. I forget now. And then the \z is the end of string, right? And then it says every time it ends a string, it implements, it execs this value. And that's how it knows which one of these routes are matched. But anyway, that's just a little bit of trivia. And the idea is that all the routes are compiled down to this efficient regular expression. Another nice thing about Chouette, in my opinion, is that it can take advantage of all the Plaque middleware. So if you don't know, Plaque is kind of this standardized interface to web servers Perl web servers and things that Perl can integrate with. So it's kind of an abstraction for if you want to run Apache's mod Perl or Fearsome, which is what Chouette uses, or any of the other Perl web servers. And also one of the nice things is that it kind of abstracts all this concept of middleware. So if you want to add like a content length header to your requests, you can just plug in this pre-implemented Plaque middleware there instead of implementing it yourself, and it's compatible with any web server. So it's kind of nice, and Chouette leverages that. And there's also some shortcuts, like if you just want to, if you just write etag, for example, you see here, that's short for Plaque middleware etag. It assumes the namespace if it can't resolve it. And then also you can pass arguments because some of the Plaque middleware accept arguments, like if you're going to do the cross origin stuff. So yeah, the default, if you call the respond method, the default output is JSON, right? It's just, you can tweak it. You can also do raw responses. You can override respond to do other things. But by default, I just assume JSON because that's how I usually end up implementing my servers. So one thing is, one interesting thing is that sometimes you want to respond and then do some other stuff. Like you might say, respond, I've got your request and I'm going to do it. and then return that message immediately to the client, and then go and do it, or do some other stuff, right? Or you might want to do initial work, respond, do more work, or you might want to log after you've responded. So there's a few ways to do that. You can either call the done method, which terminates the processing, no matter how deeply nested you are in your callbacks and stuff like that. Or you can actually just throw an exception. You can die with whatever respond returns, and respond returns the special dummy value so that you don't actually raise an error when you do that. It just stops the processing. And similarly, if you want to do error messages, you can take advantage of that too. So those are all kind of equivalent, right? So if you want to, it's kind of a nice shortcut. If you want to just say, respond, this is forbidden error, you can just go die 403. And that, it adds, it returns HTTP status code 403. It logs properly an error message in the logs, and it terminates processing there. So it's kind of a nice shortcut. And yeah, die 403 colon a message. It also pre-fills in that error message in the JSON there. Right, you can also act as the Plaque request object, and that's how you get like query parameters and path info and other stuff like that by calling the rec method on the context object. And then of course the session token integration, like I mentioned. If you're writing a web server, you're going to commonly need to create random identifiers for sessions and other things. And it's provided for you as a method on the context object. And one thing is that, it's lazily seeded. So it's not actually seeded until the first token is generated, which is something I mentioned in the session token docs. It just helps to avoid a cold restart on for example, a VM that doesn't have any entropy in the randomness pool. Right, and then as I mentioned as well, there's a log defer integration. So log defer is a structured way of issuing log messages, and you can get the log defer object by calling the logger method on the context. And then you can call like info and add an info message or warn or error. You can also add stuff to the data hash. You can create timers, like little stopwatches to start them, time in operation. And then, if you live tail the messages, you'll see, the log file, you'll see something like this. That's by using the log defer viz viewer command. And if you have Chouette installed, because it uses a dependency to pull this in, you'll have log defer viz as well. So it's you don't have to worry about setting anything up or worrying about log rotation and all that stuff. It's set up for you. The final interesting aspect, and the one that's really the most useful in Chouette, in my opinion, is the tasks. So any event task is a way to do, as I mentioned, blocking operations within an async server, right? So yeah, one of the main one of the most problematic things of asynchronous servers is blocking the event loop, and that'll really kill your performance because you'll be busy doing stuff instead of handling requests. So with Chouette, it makes it really easy to use an event task. So the first step is just to register it in your Chouette object. So along with your route and your config defaults and stuff, you just pass this option, tasks, and then you can create as many of these any event task servers as you want. And I'm calling one of them Hasher, just as an example of a task. Yeah, can you guys read that okay? Yeah. Okay. So it's Hasher is going to be the name of the server, the event task server. And that accepts some different parameters. Like for example, package is the one that's required, and I'll show the implementation of that in a second. But there's a whole bunch of other things too. Like you can say how many concurrent processes you want running, how deep do you want the queue, the backlog queue to be, and all kinds of other stuff. So then after you've done that, the next step is to actually create the implementation, and you do that just by simply implementing a normal class. You can use Moo or something if that's more attractive, but this is just the raw Perl class. So you just provide a package. That was the package that you specified in the previous step here. And then you provide an implementation. So you need to create a new method because it's a class. And then after that, you create other methods. So in this case, I've created an MD5 method, which really all it does is, call MD5 hex from digest MD5 and computes a hash. Of course, that's super fast, so it probably in real life you wouldn't necessarily want to use any event task for that, but as a demonstration, if you're doing password hashing, obviously don't use this. You can look at the docs to see a decrypt implementation. Then after you've implemented it, the last step 3, is to use it. So in your context, in your handler, you can call the task method on your context, and you provide it the name of the server that you want to call methods on. And then it'll automatically create those objects that you specified the class for in other processes as needed, and then you can call methods on them. And every method that you call, it accepts the parameters. It accepts parameters. One of them is the self object. So if you see here in the MD5 method, there's the self object that's implicit in the call. And then there's also the password parameter as the other object. And you can see when you call it, I'm providing that password as input. But then there's also one extra parameter that is provided, and that's the callback sub. So the callback sub is going to get called when the task is finished and it has a result for you. And then when it does have a result for you, it'll call it'll call that sub and provide the same thing that ctask implements. So it's kind of a reference. You can think of it as a reference to that object that was created, and also the output. And then you can do whatever you want, right? So, and the critical thing is that this callback invocation doesn't delay your event loop there. So it's happening in a separate process. And the nice thing about an event task is that you can debug what it's doing with like standard Unix tools. There's not really any limitation. You just have a normal process that's doing blocking operations. It's exactly as you would expect. So you can see if you look at like the process names, it renames the processes to be the in this case hasher workers. And of course there's a server that coordinates them, right? And if one of them gets stuck, it kills it off and creates a new one, and so on. And the other thing to kind of make this all work together is callback frame. Callback frame is a way to unify the exception handling across all these different handlers and async callbacks. So as I mentioned, the main problem with throwing an exception in an async server is that the event loop is going to catch the exception, and then what is it going to do with it? How is it going to map it back to the request to say, to give like a 500 error or whatever? Well, the typical way that that's handled is that there's this kind of usually an out of band way of signaling an error, right? So like most, async HTTP libraries have one callback for success and another callback for failure or something like that, right? With callback frame, it's there's always only one callback, and that callback carries around a dynamic scope with it, and that dynamic scope allows the exceptions to be thrown from inside it, right? Also, a library can throw an exception from inside a callback without calling the callback. So if you want like the nitty-gritty details of all of this, callback frame has some very extensive documentation. But I'll just kind of explain this little example I have here. So in this handler, I've created a DB task, an event task. And that's basically a really simple wrapper around DBI, right? And the great thing is you can call all the DBI methods. You can get back all of the stuff that DBI returns, and it is invoked separately in another process async from you, right? However, the problem is, what if you want to throw exceptions? One of the problems is if you want to throw an exception from within the handler, right? Well, with callback frame, all you do is just die, right? You just die like you would in a synchronous application. And in this case, Chouette is installing a callback frame catch block to handle these exceptions, even though they're going to be called in some other sub for you. So you don't have to worry. It'll all be tracked to the right request. The 500 error will get sent. The logs will get logged appropriately. And you can also use callback frame to try and catch these as well. So if you wanted to handle these exceptions at a higher level in your handler, for example, you can use frame try and frame catch too. It's, in my opinion, a really, really nice way to handle errors and exceptions in asynchronous servers there. And yeah, there's a whole bunch of other little details, just like I mentioned. I've all these different things I've learned and little bugs that have tripped me up in other applications, and I've tried to handle them all in Chouette, right? Just like there's the character encoding, decoding is all handled the way I think it should be. It tries to enforce UTF-8 on everything, but it handles other encodings too. Also, like I've had a couple really crazy bugs where it's logs aren't appearing, and it's because someone tries to log an object that's not serializable, and it tries to encode it in JSON and log it out, and it throws an exception on the log. Chouette, like recursive, if that happens, Chouette recursively goes in and finds the thing that's throwing and encodes that with data dumper, and then re-encodes everything else at JSON, so you have all the information. Also, log rotation with symlinks to current log files. I really like that at previous job, and it's there was not a lot of good Perl solutions for it, but I've implemented it the way I think it should be, and including allowing you to log in UTC time instead of like the log file names in UTC instead of local time. Another great thing is that you can log from the task objects, even though they're running in separate processes, and they appear in the log defer context of the request in the original server. Also, it listens on Unix sockets, which is great for Nginx support and so on, and a lot of other little details that just make it kind of a nice sort of environment for async apps. So that's it for Chouette. It's on CPAN now. You can CPAN install it. Docs are there. The docs have a lot of cross-referencing to the other modules, as you can imagine, but they're pretty extensive themselves, including like a full working authentication server in the code. In the pod. I thought I would step through that today, but I don't know. It's not that interesting if you've seen all this stuff before. So this presentation is online as well. So that's it for Chouette. Thanks, Sarah. If you have any questions, I can answer them. Sure.
Where did you get the name from?
It's from it's this way to play backgammon, which is a really, really fun way. And I just thought it was a cool name. Kind of like back rationalization is that it's a lot of people playing and a lot of hectic cross communication going on. So it seems appropriate for an async server, but really it's just because I like playing backgammon. Richard?
Does it automatically drop privileges after binding authority?
It can, but it by default no, because usually I personally recommend listening on Unix sockets and routing to Unix sockets and not even launching as root. Yeah, but yeah, it can definitely do the privilege dropping. Yeah.
But does it do it? Does it take the time to do, or you have to do it yourself?
You have to do it yourself. Well, yes. I want to put the support in there. Like what I want to do, if you have a pull request, that would be appreciated.
Mm-hmm.
But if it could say like a big warning, like you're running as root in red letters or something when it starts, that would be pretty cool. Yeah. But again, I don't really suggest even starting it as root in the first place if you can avoid it. Sure.
You actually benchmark regex versus just
no, I didn't. Right, yeah. So the question is if I have any hard benchmark evidence that regex assemble is faster than a loop. No, I didn't. No. I'm just assuming. No, I mean, yeah, it's in the very least, it's not going to be substantially worse, I don't think. Yeah, so no, I didn't, but that's a good question.
In your tasks, we're trying to output, is there any limitations in there? Is it expecting string or is it serialized?
Yes, there are limitations. It needs, in the master branch of the implementation, which is what Chouette uses now, it needs to be JSON serializable. Yeah. I have an experimental branch where it uses serial, which is another serialization that has a lot more flexibility. Like you can handle weak references and circular references and stuff like that. And another really interesting experimental aspect that I've kind of been working on, I was working on, is a way to encode references to other results. So what you can do is you can create like some object that can't be serialized, and then it returns like some special little reference, some like unfalsifiable reference to your async client. And later on, you can call methods create objects that can't be serialized and still interact with them remotely. Yeah, at a distance. Yeah. And the other really awesome thing that allows you to do too, I have another presentation where I explained this, is it actually allows you to do pipeline, right? So you can actually say, create this object and call this method on whatever it returns, and then whatever that returns, add this number to it, and then call this other method on it or something, and send it all in one packet. And it'll actually, it pipelines all those instructions and does them in order as you specify them, and then returns the result to you. So it's a lot more efficient than going back and forth through over the JSON protocol. Yeah, it does. Yeah. But the nice thing is that because the exceptions are thrown and then rethrown in the calling process, it would just abort the pipeline. But yeah, you're right. Like reporting where actually it failed is a lot more problematic there. Yeah, that's a good point.
If I can just interject, because I am stupid and forgot to start broadcasting, so we lost maybe the first 30 seconds. I just wanted to say again for the video record, this is Doug Hoyte giving what was supposed to be a double Doug night is now a triple Doug night. Thank you to Connected Lab for hosting, and it turns out to be a bit more logistics, and particularly to one Matt Gosby down the back, because we need co-hosts, and he stayed behind so I could host this tonight, so thank you very much. Back to you.
Yeah, thanks to the Connected Lab for hosting us here there.
So this is a 3 Doug night, right?
It is.
Triple Doug.
Yeah, the rest, both these talks are a little shorter than the previous one. So this talk is about something I've been working on in the last few weeks there, and it's about this new company I'm starting, named Log Periodic, and this is one of our products there. So consider this script. So can we see that all right, or do I need to make it bigger?
That's good.
Okay. Tell you what, I'm going to go over here right away and look at it. Okay. Oh, yeah.
That works.
That's better? Okay. So, can anyone think of anything wrong with that script? Is that going to work? So,
Python?
So we're creating a web server, so we're starting a web server, listening on port 9876. Simple HTTP server is just this HTTP server that serves the current directory, and you can download files. And then we're calling curl on it to download the file. -I is just to do a head request instead of a get, so that we don't spew a bunch of directory stuff in there. And then we're going to kill the web server.
Curl runs faster than the server starts.
Alex, yeah, or
Well,
yeah.
I was gonna guess you were gonna kill the web server and leave the kid lying around as a zombie.
Possibly, yeah. Usually, so if the script failed and I didn't kill, that could be a problem, yeah. But yeah, Adam and Richard, I think, had another suggestion about what I'm going for. Is
Curl runs for the server starts.
exactly. So Python is gonna start, and it's gonna take a little while to actually compile all its modules and start the server and bind. And by that time, curl has long since failed, right? So if we run this, we'll see. Yeah, so failed to connect to localhost port 9876. Connection refused. Well, that sucks, eh? So what do we do about that?
Just serialize it.
Serialize
it.
Put a sleep command in. Exactly.
Brute force.
Try the 60.
So we'll go. All right, let's see. So where do I sleep? I sleep before curl, right? So how long should I sleep?
Try 60.
60?
That doesn't work out.
I can tell we have a real enterprise coder here. All right. I'm just going to sleep for 1 second. 1 second should be long enough, I think. Okay. So I'm sleeping for 1 second. Hooray. Okay. So yeah, serving HTTP.
Ship it.
Ship it. All right. So yeah, the problem is that what I described, there's a race condition, and the common fix is to add a sleep, right? But I would say most people acknowledge that sleep is not the ideal situation, right? The first problem is, how do you know you're sleeping for long enough, right? Like 1 second might seem like a huge amount of time, but like what if there's some NFS glitch or something loading the the Python modules, or you know, just some non-determinism in the run, or the server's really busy or something, and 1 second's not enough, right? Well, you might choose, you know, to go up to 60 or 300 or whatever, but then of course your test suites become a lot slower, right? And we all know the disadvantages of long test suites. You have a long cycle between when you actually do a change and whether you know it was successful or not, and it, you know, is a lot slower to release stuff, and so it's not ideal, right? So somehow the server needs to signal, right? Like the correct solution, most people acknowledge, I think, is to have somehow the server indicate, I am ready now to accept, and at that point to run and proceed with your testing of the server, right? Unfortunately, pragmatism almost always wins in this case, in my experience. And the problems with these are that, you know, often you have to change code, and sometimes it's like a big change. And maybe you don't even own some of the code that needs to change, right? Like off the top of my head, I can't think of an easy way to do that with the Python, right? Maybe you could like wait until it prints out the start message or something like that, or like something. Yeah.
Could you do that if you had the and at the startup, the first half of an and the second one, because he's not going to start evaluating the first one until he's finished the first bit.
Well, the thing about that, the question is whether we could just run the Python server to completion and then run the curl, or
the two was part of an and, yeah.
An and, right. Well, the thing is that the Python one is actually never going to stop executing, right, until we kill it. So, and you can kind of see there actually is the and background process there command. So it is in some sense running as an and. So yeah, the problem is that they are running concurrently, right? So there's not really any way we can run one to completion or any before we run the curl, right? So yeah, that's kind of the issues. And yeah, we don't own the code to simple HTTP servers, so it's not as simple as just like, you know, we can send a pull request in to like have some, you know, special socket that's closed or triggered or something when it's ready or something. But you know, they're probably not going to accept that change or whatever, right? We could hack our own local copy, but that comes with a whole bunch of other issues. And the pragmatic aspect is that companies often have these huge test suites, and they don't want to invest in them. They just want them to work, right? And I can completely sympathize with that. It's, you know, if you've got your managers breathing down your neck saying, we need to release this now, we don't have time to invest in this testing. You just want it to work. So let me introduce log periodic. So what we can do is add this, create this file in our directory called .logp.com. And I'm just going to copy paste this in there. I'm just going to, yeah, okay, we have it there. Okay, so I'm just going to paste it in. So what this is saying is, under this trace subcommand, which I'll show you in a second, I want to sync the port 9876. Okay, so after we've put that in our file, we can go log p trace, and then we run the test.ash command. Okay, that worked, but we still have the sleep in there, right? So let me just comment this sleep in there and see if it still works. Bang, it does. So log p solved that problem for us, right? Like it helped us, and it gave us back some determinism. And just for a demonstration, so there you go. Enjoy your deterministic test. Moving on to the next slide. So suppose we have this huge test suite, and we don't want to comment out, or we don't want to, and we solve the determinism problem. Now do we have to go and delete all of those sleep commands? Well, not necessarily. I'm going to put the sleep command back in. I'll put the sleep command back in, and now I'll open up the config file, and I'll add this other parameter, the sleep speed up parameter. Sleep speed up is true.
Why isn't it power nap?
Power nap, yeah. And now log p trace, test, bang. So even though it's sleeping, even though it has a non-determinism aspect to it, it still succeeds. And that's kind of the value of log p, right? Is that you can have, Matt,
Actually good. It's magic.
I'll get to that in the next slide. But yes, what is it actually doing? Very good question. So yeah, but that's the value proposition, is that you can have this big test suite, hairy code written in a whole bunch of different languages, and it's non-deterministic, and log p is going to help you gain some control over that. So to Matt's question, how the heck does this thing actually work? So it's a little bit convoluted and a little bit of a hack, but it should be pretty reliable. The best kind. Okay. So log p is, when it runs, it starts as a master controller process. And the first thing it does is it opens a Unix socket in like some temp folder. And then it puts that Unix socket into an environment variable. And at that point, it starts spawning the child. So it takes all the arguments in the command that we ran and that we put in after log p trace, and it forks and execs that process. And that while it's doing that, it also sets an LD preload environment variable, which is actually going to replace some of the libc functions like connect and bind and listen and nanosleep and so on that we're using here. And it replaces them with its own little special implementation. And that implementation, each one of those children, once it starts, this is something that's already also added by the LD preload, is that it creates a connection to that Unix environment variable. So it looks in its environment, it sees like the log p Unix socket environment variable, connects to that, and this is before it's even run main. And it says, hey, I'm this process, and I'm about to run these arguments and so on. And then the master controller process says, yes, go ahead. Or it says, wait for a bit, whatever. And then once the child starts, when it runs these interposed functions like connect and bind, it will actually, depending on how the Unix or the master server is configured, it will either tell the process to just go ahead and run it, or it'll say, check with me every time you run a connect, or every time you finish running a bind, or whatever, right? It can intercept these function calls in various ways. And in this case, the sync port command, it just says, every connect you run for this particular port, let me know first before you run the connect, right? And I'll tell you if it's okay to go ahead. And then it also says, hey, if you're going to bind or listen to these, if you're going to bind to this port, or you're going to listen on anything that you've bound, check with me after you've done it. Okay, so then when Python starts up and it runs and runs and runs, and then it's ready and it does bind and listen, it says to the master controller process, hey, I'm done. I'm listening now. And when curl runs, this is before any of that happened, it says, hey, I'm connecting. And the master process says, whoa, wait a second. It's not ready yet. And then as soon as it is ready, it's notified by the Python process. It allows the other one to proceed. So it's completely transparent. It works with almost any language. And that's basically how it works. Alex?
Do you handle chaining? So if you have something that's continually binding and then connecting and dropping and then binding and connecting, do you handle that sequence of events, or is it just a one-to-one?
Yes, I do. The question was whether it works if a port is getting bound and then closed and then bound and closed in a loop or whatever. It does handle it. Yeah, it keeps track of the periods of time that the socket is bound, and only allows connects to proceed in that time. That's what sync port does. There's more advanced solutions, but yeah, sync port basically says, I'm going to assume that something is going to listen on that thing, and anytime it tries to connect, if that thing is not being listened on right now, block it until it is. Yeah.
What if you want to test a closed port, like test failed?
Yes. That you can. Do you mean in the same test as one that succeeded?
Yeah.
You can. Well, you can't exactly do that right now, but I have plans for that in the near future. Yeah. Yeah. No, I'll come back to that actually in the next slide a little bit. Alex?
Yeah. So I have the question, in your script, you go sleep one. Does the sleep one continue to run to completion before we actually see the prompt?
So
Or does it short circuit the sleep because everything's finished?
so
Like, can you make that a sleep 10 and we run the script and see if everything works?
yes. So you mean when log ptrace is enacted, right? When it's running, but
Yeah.
like yeah. So it does allow it to run to completion. However, it tricks it and it says that yeah, you've slept 10 seconds. So sleep.
Okay, so there is a trick there.
Yeah. So it runs to completion and it thinks it's slept the entire 10 seconds, but actually nano sleep returns immediately. That's what the sleep speed up does. It just says all sleeps, stub them out,
Sleeps go
and
through me.
yeah, sleeps go
So
away.
you're hooking sleep.
Yeah. You could also it's very generic. You can say you could actually ask it to connect to the master process and check to see how long it should sleep or how if it should return immediately or if it should get triggered by something else, right? But yeah, the sleep speed up config parameter says to just stub out all sleeps and just let them go through, effectively 0 seconds. Yeah, but you could put I could put sleep and then log p trace. And they'll still work instantly. Right? Other Alex?
So you have, you said it supports like soccer functions. Does it also support file descriptor stuff right now, like write training is soccer?
No, not yet.
Okay.
However, I have some prototype code that allows it to do that.
That seems a bit more complex on that side.
It's slightly more complex, yeah. But yeah, other features that I want to add are fixing other race conditions, like you said, file system access. Also database access. I have some ideas on how to stub out. The nice thing about LD preload is that it as opposed to, for example, ptrace, is that it is not limited to system calls. So I could actually intercept, for example, ODBC calls or anything that's dynamically bound, right?
Yeah.
So yeah, I have a lot of ideas for that, but that stuff's not exactly implemented yet. I'm waiting for a good, fairly easy use case to solve for that one. Yeah. Another thing is if you have two things that are just pure racing, and like say your output is getting jumbled around in weird ways, and you don't want that, you could enforce a concurrency ordering on them. Another thing is dates and times. Like suppose your thing always runs. Your test always works, except when they run it over at like 11:59 p.m. or something, and then it breaks as the day rolled over. Well, you could stub that out and say always pretend I'm running at noon, right? No matter what time it's actually started at, and without requiring root access to change the clocks or anything like that. Another thing is random numbers. You can make it so that devu random always returns the exact same sequence of bytes every time you read from it. So you can enforce a lot of determinism, which is useful for testing. But that's not my only vision for the technology either. Another thing is that you, as Alex was asking, you could actually say these connections that would otherwise succeed, simulate them failing, right? So, and then you could verify that your application is actually handling that properly. And you could actually say, run the trace command in a debug mode and see how many times it's connecting, and say, run my test 100 times. Let's say it connects 100 times. Run my test 100 times, and the first time fail the first connect, the second time fail the second connect, and the third connect, and so on. And make sure it does like the same thing in every single one of those, right? You could also use it to exaggerate the non-determinism of your tests, right? So like often your tests will have race conditions, and they'll never get exposed, right? And sometimes that is actually indicative of a real problem in your application. So you could actually use this to exaggerate the race conditions and say, make sure that this thing runs out of order, right? Like, simulate that the Python always starts faster than the curl runs, right? Another thing is, you could do the opposite of what I was saying there about the 11:59 runs, right? You could make them so it always runs at 11:59, or you could simulate daylight savings rollovers in your code, or you could simulate the Y2K38 problem in your code, right? So there's all kinds of different other kind of use cases for it to add, to enhance your testing too, and not just make it more reliable. And that's where I am right now. I'm looking for test suites that have bugs or are slow. If you have any of them, I'd be interested in helping you work with them, see if our technology can improve them for you. So if you have any of those or know of any of them, drop me a line in my email there. Just
You mentioned earlier on that this might work for most languages. Certain things where this won't work.
yes. So the question is, where won't this work? Where won't the LD preload trick work? So it won't work in the cases of a statically compiled binary. So if you statically compile instead of dynamically linking a binary, it's unable to interpose those function calls like connect and so on, right? So in that case, it won't work. Also, some other languages, like I'm only really aware of one, Go, it doesn't actually link to libc for a lot of its stuff, so it won't work with Go. Yeah. However, I have some other ideas of how to do it with Go, mostly involving ptrace, where it will work. But of course, that means you can only intercept system calls. There might be some Go-specific interposing possibilities, but I haven't looked into it yet. But yeah, I would say like the vast majority of things are going to work. Yeah. Yeah. So that's talk number 2. Thank you, Alex.
What does Go do for libc then instead?
As far as I know, it actually compiles in its own system call interrupts into the binary.
Really?
Yeah. So they're like, and it statically links everything into its binary.
Yeah.
I think like the latest Go's have a way to link to like libgo, so that that's not duplicated for every application.
Okay.
But previously, it used to just bundle everything up into a huge binary. Exactly. Yeah. Libgo, whatever the equivalent is. Yeah. And that's why they're like 10 megs each binaries or whatever, right? Yeah. So that's talk number 2. All right, the next one. Thank you. The next one is kind of a little bit of an oddball here, but so there was just recently this amateur radio event called Field Day, and I went there with a few other people here too, in fact. And one of the things that I always really love about Field Day is watching some of the old guys do the CW, the Morse code contacts over the air. And I've kind of been slowly getting into it myself too. So this talk is about just sort of the history and the evolution of the telegraph or Morse code key. And I've brought, yeah, so actually for this talk, I guess I'll.
So do we have to upload in Morse?
Oops. Sorry. Okay. So is the Hangout showing? I wanted to show the video too. Oh, it's no, it's not. Okay.
Well, I think we know exactly how this works. Now I can see it backwards. That's probably not designed.
Okay. Well, anyway, it doesn't really matter, I guess. So I brought some keys here. Okay. So yeah, the first the like original type of key is called the straight key, and it's basically it's a very simple design. It's really just like an on and off button, and you can just you just tap it, you close it. Normally it's open and it's not connected. When you press down, it's closed, and it sends a tone over the air or an electrical message over a line. this is what you see in the movies. They're always using this. And it's been around forever. Mid 1800s. I tried to do a little research. I couldn't actually find a definitive source of when this thing was invented. But yeah, there you go. The problem with it though is that operators that used it all day developed like this repetitive stress injury, and they called it the glass arm, and it was really bad. Right. But before I get into that, another thing, when they first invented wireless communication, they didn't have good relays, obviously didn't have transistors, so they had no way to make it so that you could use a very safe small voltage key to control a high voltage oscillator. So they actually had to design keys that were extremely well insulated, like for example this Marconi key, and that thing would be handling hundreds or thousands of watts of power and so on. And the next kind of evolution is what's called the side swiper key, and the idea of it is instead of going up and down, you go left and right, and it's very simple design as well. It's just there's actually two contact points, so there's left and there's right, and you could go like typically what they would do is go in a symbol, like for example A, you would go dit da, and one direction you would do the dit, and then flip over to the other direction and do the da, and kind of the break between them would be kind of a length of time between you flipping it back and forth, and that alone saved a lot of repetitive stress injury problems for the operator. And then the next really big invention was the vibraplex, also known as the bug. I guess because original versions, I'm not sure about this one, but originally they would kind of actually look like bugs. And the really neat thing about the vibraplex is that it's a purely mechanical design, but it's what's called a semi-automatic key. And the thing about that is that it would actually create the dits, the short portions of the signal, the symbol, automatically for you. So they would be perfectly timed, and if you had a whole bunch of them in a row, the spacing between them would be perfectly timed too. And the way that it would work is that it actually has a pendulum built into it. This part here, if you get a chance to watch the YouTube videos, it's really cool. So this thing, when you hit it to the left, when you hit the big paddle here, the pendulum that would start rocking horizontally back and forth, going like this, and making contact every time, going dit, 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 dit. So if you hold down in one direction and go dit, 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 dit. And then the DAWs, however, would still have to be formed by hand. So if you go the other direction, you press that paddle there, the round part, you would hold it down and it would just continue to make contact. So in order to do, A, you would go dit, release it. That dit would be perfectly shaped and timed, but then you would manually have to hold the DAW for the amount of time.
Just so you know, Doug, you're not mirrored anymore. I've got two screens.
Right. Yeah. Sorry. I know. I just I wanted to try and get it so that they could see me as well, because I was going to demonstrate. But yeah. So also a very old design, patented in 1892, and then it became popular in 1904. But then, yeah, the next real big evolution was the electronic bugs, right? So they basically took the same kind of concept, whereas it's a side swiping sort of design. You go left and right, and one of them are dits, and then the other direction are, in this case, DAWs. So they actually completed it and made it fully automatic. So holding it left, it would go dit, 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 and then holding right, it would go da, 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 right? So if you wanted to go, O, you would just hold right, da, 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 release, right? And it would be perfectly timed. The spacing between the DAWs would be perfectly timed too. One of the kind of interesting things about the perfect timing of the symbols is that it actually eliminated what operators call the fist of an operator. So normally, previously you would actually be able to hear, based on the style of keying, you'd be able to recognize individual operators, and they would say, oh, that's Jimmy over there. I know his style because he creates his dits like this and his DAWs like that. But with the invention of the electronic, everything is perfectly timed, so it gets rid of what's called the fist, which is like being able to recognize someone's voice or something like that.
1940s and 1960s.
Yeah, so this one I wasn't actually completely able to get pegged down in the dates either, but I found a transistor, or sorry, a tube design for the keyer from 1940. And then everywhere there's this one called the L bug, like EL bug, electronic bug, from 60 something or other, and that became really popular, and that everyone started using it. Yeah. So I don't really know the exact dates. There's some.
Was there much professional use of Morse in the 60s?
Yes.
Yeah, absolutely, yeah. Especially like in naval usages and long distance plane flights. Yeah, and of course amateurs. I mean, but you asked professional.
My grandfather was a manager of CN Telegraph in Halifax until 1973. They closed the office when he retired.
Yeah, I mean, I'm sure it was fading out, of course, but yeah, I think it was still. I mean, yeah, yeah. I think we talked to someone from the military and said they still use it on ships for something. So it's like a backup or something like that, I guess. But and then the final evolution, I guess, is this modern design called the dual lever keyer, or the dual lever paddle, and it's usually hooked up to something called an iambic keyer. So, yeah, iambic is like, think like Shakespeare. Iambic pentameter, like da-dum, 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 right? Each one of those is an iamb. It's from like a Greek, I think. And the idea behind that is that if you squeeze both those paddles, right? So as you can see, it has two paddles. The same kind of idea is you hold left, you're going to get dits. You hold right, you're going to get daws. But what if you squeeze both of them together? Well, with an iambic here, you get da-da, 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 or da, da-da, da-da, like starting with a da, depending on which one you pressed first. And I have an iambic here too.
Want to hold it up to the camera for a moment?
Sure. Yeah, this is a iambic here. So dual lever paddle, and I'm going to hook it up to an iambic here. Yeah, this thing I built myself out of a teensy kind of Arduino thing. So first I'll hook up the straight key. Yeah, when you turn it on. Oops, sorry. Let me do the iambic one first. Yeah, when you turn it on, it goes da din, which is R for ready. So yeah, as you can see, holding the left, I don't know if you guys can hear that or not. Dit, 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 dit. If you hold right, da, 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 da. And if you hold them both together, da, 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 da. Or if you press the da one slightly first, it starts with da, right? So yeah, the nice thing about that is if you want to do like a C, da, 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 it's just one motion, squeeze, release, right? And if you, I mean, I've been practicing, but I can get like some parts of my call sign, like Y is da, da, da. So it's just go back and forth, right? And that you use the da 2 times. So like, here's my full call sign. Yeah. And then another neat feature of my keyer there is that I have these 3 memory buttons. So if I press this one, that's 2 letters, CQ. That's kind of the standard call, like I want to talk to someone, CQ. And then if you have the middle one, this is my call sign again. And you can always press the button to press a key just to stop it in the middle if you want to. And then the 3rd memory, I haven't programmed anything into it, so it makes this kind of noise. Blue. Yeah, and then another neat feature is this button called the setting button. If I press this 1 time, it just starts going dit, 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 and then I can slow it down or speed it up with the paddle here. So if I want to speed it up, I hold down this one, and then if I press the setting one again, it saves it. Now listen to how it plays my call sign. And like, which is way too fast for me. But if you listen to the error, people actually go that fast, right? So I'm going to slow that down to a little bit more manageable. And then, yeah, another thing is if you hold this down for long enough and the light comes on and you release it, you can actually change the frequency of the side tone, it's called here. So you can select whatever is comfortable for you. Again, to save. And the final thing I'll show you is you can change the type of keyer you want. So right now it's in iambic mode. That's this first one. So if I press this and press the middle one, it goes did for S. That's straight key mode. So now I can actually plug this guy in and go like this. Yeah. Right. And the other thing is that this thing doesn't just actually make noise. The typical idea is that you connect it over to your radio, and it uses a MOSFET to actually trigger the keying. So it's in fact usually you would turn off the green thing, and it doesn't make noise anymore. It's only for triggering the radio, right? And then the final mode is the vibraplex mode. So if I hold setting, go to the 3, da. Yeah, now it's in vibraplex mode. So because it said V, right? So if I plug this guy in, now it's in vibraplex mode. So holding left is dits, right is just DAWs. So I have to form the DAWs manually. But generally speaking, iambic is the preferred mode, so I keep it there. And yeah, after the talk, you can come up and play with them if you want, or see it. I'll open it up too, and you can see the insides if you like. So that's it. Thank you. Yeah, question?
How many QSOs have you made?
With Morse code at CW? With this? Oh, none. I just finished it 2 days ago. Yeah.
I failed to mention it, but you got some claps for your last presentation online, and now you have claps with exclamation points.
Oh, thank you. Yeah, I would say probably, yeah. But I mean, especially based on the fact that everyone that does it in the Toronto club is over 80 years old, probably. Well, not quite. Over 60 at least. Yeah.
But what would be still some of the advantages of, let's say, Morse code over other modes?
Good question. Yeah, well, Morse code definitely has its place. I think, especially in like noisy conditions and low power conditions, it's easier to get a signal across, right? Like with voice, you typically need several times more power to actually communicate than compared with CW. Yeah, CW is another, like usually amateurs call more like Morse code communication CW for continuous wave. You kind of have like a continuous wave signal that you're interrupting, and that's how you form Morse code. So
I remember 10 or 15 years ago, there was some disaster in Mexico, and the amateurs did a lot for communication. Is that still like that?
Yeah.
Or are there alternatives?
Yeah, definitely. I mean, there are some alternatives. I think a lot of it is moving to digital modes, like PSK31. But I think, yeah, some amateurs still swear by CW. Yeah, our club, we actually do this exercise sometimes where we simulate there's some emergency in Toronto, and you have the different Red Cross centers and the hospitals try to relay messages back and forth. So we actually, try to get the messages back and forth through different ways, whether it's digital, voice, or CW. Yeah. So, yeah, I mean, it's hard to say in 50 years if people will still be doing it. I have no idea, but I think probably some amateurs will keep it alive. Yeah.
Same reason that people still play with steam engines.
Sure. Yeah. True.
Interesting, and in some ways, the old technologies are more accessible.
Very true. Yeah. Very true. Yeah, like it's much easier to build a CW radio than it is like a single sideband radio. Yeah.
So when are you going to build the receiver portion of this to automatically decode Morse code?
Yeah,
Send out ASCII key.
Yeah, well, that's a lot more complicated. Yeah, maybe someday.
I've seen you take over remote control cars. Come on.
Yeah, there's some really neat implementations of it that you can do. You can build like a search tree, right? Like, if you can get the symbol to decode into if you are getting dits and DAWs and you can reliably decode that, how to traverse the search tree. Well, you start with the root being dit, and then if you go, left with another dit, you get I. If you go right, you get A, and so on, right? And you can build up that entire tree. And so it's really easy to really efficient to decode even in a tiny micro like this. Yeah. Well, thanks. Yeah, come up and play with it if you like there. It's I think it's an iambic mode right now. Yeah.
We'll just take a quick peek at the inside. Woohoo! Because this is exciting.
And then, That's CQ.
Right.
Okay.
It's really cool.
There's
Are there any
something wrong.
questions from online?
Oh, right. Yeah.
There's something wrong when the computer is smaller than the battery.
Very true.
Wow. That is
Unix
that's
says thank
astonishing.
you for the spectrum of different
Oh,
topics. that you
spectrum
provided.
of welcome. You're welcome.
Technologies, yeah.
What's the current draw on it? What's your runtime maybe on that typical level?
Good question. I think it's good. Yeah, good question. I have to look at the teensy. I think it's like I think it's drawing like 30 million amp or something.
Yeah, so if you're using this, let's say during field day, would you be able to get a single set of batteries, or do you the whole?
I think so. I haven't checked it, but yeah, I think so. Yeah.
Time to do some quality control and
Sure. Another thing is you can actually. Oh, that one I didn't hook up yet.
Yeah, I'm just trying out
Oh,
the
sure.
mechanics.
Yeah,
Sign off
I
the broadcast
I can actually
now.
do
Thank you
it
very
through
much,
USB.
everyone online.
power it through USB as well.
Cheers.